And the third example of open-closed principle I wanted to show you, and it is really similar to the previous one about reports and PDFs and CSV and XLS. And this time it's about salaries of employees in a company. And depending on the position and years at work, the salary may be different. These formulas are just simplified numbers. Don't pay attention to how much developer earns or designer or director. So this is the table. For example, you have the list of names, and depending on the position and on years in the company, and years in the company are calculated by start date, the salary is calculated. And you can do that with switch case or if else. So if there is a director, there's one formula, developer another formula, depending on years and on some magic numbers like base salary, like bonuses, stuff like that. And again, it violates open-closed principle because it is not closed for modification. So if you add another employee type, I don't know, like secretary, whatever, accountant, you need to add another case here. And it may be quite a big formula, so it will grow that class bigger and bigger. That class, by the way, is employee model, which is getSalary attribute, which is an accessor. So in index blade, you have employee salary, and that salary is transformed in Eloquent to getSalary attribute. So it is calculated on the fly. So in employee controller, you just get employee all, and this is all happening in the model, which is okay. But we could make it better and create separate class with method calculate to calculate each position salary. So in case of new position, we just create a new class for that position with method calculate. And guess what? I already did that. In the folder app calculators, you're free to call it whatever you want. So app calculators, in the app folder, you can create whatever folders you want. So designer salary calculator, for example, it has a namespace of app calculators, and only method is calculate, and start date is the parameter. And also it implements salary calculator interface, that thing that we discussed previously in another example. So salary calculator interface is the rule for all possible calculators in the future, and it has the rule that it has to have method calculate with specifically parameter start date, and it needs to return float. So in the calculator, you need to do exactly that, and you can just take care about the formula itself. So then in the employee model, instead of this switch case, we have something like this. I've prepared it previously. Let's close the sidebar so you would see that. So you need calculators array with set of classes. So for each type of employee, there is a class. So calculators array and then the element of that employee type or employee position. And then all you do is call calculate depending on the start date. So you don't need to calculate years inside here, and you don't need that switch case. And this is another way to define the class that is responsible for that operation. In previous example, we had class name populated dynamically, and we can do that here as well. So for example, another option B, as I called it, calculator class name. Instead of that return, we define calculator class name, and then we call that here. So it is shorter, but maybe it is more readable or more clear for other developers to have it as a separate array and add another class to the key of string value of employee type. So choose your option. But in any case, if we need another salary, another position, we just create that separate class with the method calculate and define the formula inside. And then it doesn't violate open-closed principle, because the employee is kind of closed for modification, but it's open for extension, and extension is a new class.